Okay, so we have these two solutions, but we don't know what x1 and x2 might be. Okay? Well, we have to take each solution and plug it back into this equation and determine the x1 and x2. When we do, it's a little more complicated because like 1 minus lambda, let's just take the first eigenvalue with a plus. Okay? So we get the real part and the imaginary part. Just came out of the quadratic formula. Okay? And we're going to be 1 minus all this, which gives us this. And we're going to still have our 3 because that's not going to change. Neither is our negative 1. But then we're going to have 2 minus all this, right? Times the x1, x2. And that's ultimately got to equal the 0 vector. But let's go ahead and simplify a little bit. First of all, we collect our real parts. We get a 1/2 here, a negative 1/2 here, and 2 minus 3/2 gives us a 1/2, right? We still have our imaginary parts, our negative 11, square root of 11 over 2i. And then we have the 3 and the negative 1 here. Okay? So if I multiply that out, I have this times x1. Well, here it is. If I close the parentheses, it would be there. Okay? And now my I is kind of... Okay? And a 3x2. And I have a negative x1 here, and this quantity, the 1/2 minus the square root of 11 over 2, and the I is inside the parentheses. So I don't know that I made a mistake there except writing a couple of I's carelessly. And screwed that up and didn't close that parenthesis. Okay, you got to be careful. Right? Now these equations should give us x1 as a multiple of x2 or x2 as a multiple of x1. Okay? And we should get the same multiple for either equation. Now, the way the complex numbers work out, that should happen. I don't have time to work out the details, the complex arithmetic there, but I probably will next time. But just taking our first equation and on faith that it's right, and if it is, that the second equation will give us the same thing. Okay? I get then negative 1/2 plus the square root of 11 over 2i x1 equals negative 3x2. Right?
Right.
So it's a simple matter now. To get x1 as a multiple of x2, we just divide by this complex number. Okay? So that x1 is negative 3x2 over, well, okay, I got a negative here and a negative here, so I'm just going to have over 1/2 plus the square root of 11/2 I. Okay? But that's not in standard form for complex number. And we want to be able to deal with it in standard form. So how do I divide 3 by a complex number? How do I divide by a complex number?
You're flipping it.
You can't flip it. Doesn't work.
But, well, you end up using the
Complex conjugate?
yeah, conjugate.
You multiply both numerator and denominator by the complex conjugate, so you know that. And that's really easy once you learn to do it.
Yeah.
Now the people that are coming in right now are going to have to learn to do this soon. They're going to need to learn to add, multiply, subtract, and divide complex numbers. The first 3 are really easy. The last one, they're going to find that tricky. Don't mean to talk about y'all while you're sitting there. Okay. So we get 3x2 over, what, the square of this minus the square of this, right?
Right.
So it's 1/2 minus 11/4 multiplied by 1/2 minus the square root of 11/2 I. Get the I in there before I close the parentheses, maybe next time. Okay? So that equals what? Well, 1/2 is 4/4 minus 11/4 is 7/4, so it's 4/7 of this, right?
Right.
So it's 12/7. And then 12/7 of each of these, right? So if I get that right, that's going to be 6/7 minus, and again, 12/7, so it's going to be 6 square root of 11 over 2 I x1, and your solution, and every step I'm taking, except the complex arithmetic, is the same as the steps you take if you have real solutions. Okay? You just got to keep your wits about you and hope you get the algebra right, and then check it out and make sure, and then go fix it if you didn't, which is motivation to do it right the first time. Okay? So anyhow, we have this, so that your solution y1 is what? It's I didn't leave myself enough room. Let's try to do this uniquely one time, get it right. Okay. It's going to be your e to the 3/2 t times the cosine of the square root of 11/2 t multiplied by the column vector. And this is x2 over here, not x1. And it's not written very well, but I think we understand it, okay? So it's x2 and 6/7 minus 6 square root of 11 over 2 x2. Now we plug that back into the original equation, and I left the I off of this thing. Okay, we plug that back into the original equation and see that we have a solution. Okay? So the arithmetic is, you've got to be careful, there are more steps. But it's just complex numbers. And if you remember anything about multiplying by the complex conjugate, you know enough about complex numbers. Okay? So you'll be good on this. Okay, now double check my arithmetic. And double check and see if that doesn't constitute a solution to the equation.